In this experiment, we shall measure the speed of sound wave in air. For this experiment, we require the following things. A dual trace oscilloscope, a signal generator and a loudspeaker, a rule, and a microphone connected to an amplifier and to the oscilloscope. We start the experiment by switching on the signal generator, and we will see the trace on the oscilloscope showing up. We can count that there are two divisions between two peaks, and the time base is set to 1 millisecond. So this means that the frequency is 500 Hz. We switch on the loudspeaker and hear the sound coming out. We also switch on the microphone. The signal picked up by the microphone shows up on the screen. This is the upper trace. We use the controls on the oscilloscope to align the two traces together so that we can compare the peaks between the signals. We then move the microphone away from the loudspeaker and observe the two traces on the oscilloscope screen. The first obvious observation shows that the signal decreases in the amplitude as the microphone is moved away. We will also note that the signal picked up by the microphone moves relative to the signal coming out from the signal generator until the two peaks align themselves. And this is the point when the two signals are in phase. We use the rule to read the distance between the loudspeaker and the microphone. But in order to do this so accurately, we remove the grill of the microphone so that we will locate exactly the pickup. We use the no parallax method to read the distance by moving our eyes to the left and to the right, and we know that the distance is 56.4 centimeters. The frequency is 500, and using v equals f lambda, we find the velocity of sound to be 282 meters per second. We repeat the experiment by changing the frequency of the sound wave, and then we will compute an average value for the velocity of sound in air.